All right, grade 12s, good evening and welcome back to our maths class. Guys, here we are requested to prove the identity, okay? Which is cos 2x plus cos squared x plus 3 sin squared x divided by 2 minus 2 sin squared x, which is cos 1 divided by the cos squared x. So whenever you have an identity like this, you know that you are going to work with the left hand side and the right hand side, okay? So it's basically left hand side and the right hand side. So in this case, you need to check the most complicated side between the two sides. Which one is as complicated in this case? Obviously is the left hand side, okay? Because the right hand side, you can see that we only have 1 divided by cos squared x, which is not complicated. So now we can work on this left hand side. So we're going to say left hand side, it is equals to our cos 2x plus cos squared x plus 3 the sin squared x divided by the 2 minus 2 sin squared x. So in this case, guys, you do not have to stress yourself. You just have to look at what you have, okay? And then you know that you are being guided by the right hand side in this case. So you need to check the right hand side, how it has been written. So in this case, this is 1 divided by cos squared x, meaning that the numerator in this case, we have to make sure that it is 1 and the denominator is cos squared x. So in this case, let's firstly change this double angle, and then you do not have to change everything because there is double angle, and then we do have the fundamental identities. So in this case, you can just forget about these fundamental identities, but you change this cos 2x, which is a double angle. So this cos 2x, it can be written as cos squared x minus sin squared x, or it can be written as 2 cos squared x minus 1, or it can be written as 1 minus 2 sin squared x, okay? So in this case, now you can just say the cos squared x minus sin squared x, it is equal to this cos 2x, right? Plus cos squared x plus 3 sin squared x. I said that you need to for now you need to make sure that you do not change these fundamental identities, okay? And then you divide by 2 minus 2 sin squared x, and then from this part here now, you can check the like terms, okay? You check the like terms, and we do have this cos squared x plus cos squared x, which is 2 cos squared x, right? And there is this minus sin squared x plus 3 sin squared x. So in this case, the coefficient of sin squared x is 1. So it's basically minus 1 plus 3, which is plus 2, because we always take the sign of a big number. So the big number in this case is 3, right? Our sin squared what? X, all divided by 2 minus 2 sin squared x. So from this step, you can see that you do have binomials. So whenever you have binomials, the numerator is binomial and the denominator is binomial, right? So you need to make sure that whenever you see a binomial, it means you need to factor out something, okay? So in this case, you can factor out what? You can factor out 2 for numerator. So it will be 2 open bracket cos squared x plus sin squared x, all divided by, even in this case, you need to factor out 2 open bracket, and then you need to check the number that you can multiply with 2, and then at the end of the day, you are going to get 2. So this will be 1 minus what? Minus the sin squared x, okay? So in this case now, you are basically done. So you do have 2 multiplied by cos squared x plus sin squared x. So here there is a confusion, guys, that I've realized. Most learners, they fail to write one here because they only know that the fundamental identity, which is sin squared x plus cos squared x, is the only one which is equals to 1. Okay, so if you can check, if we rearrange this is cos squared x plus sin squared x, which is also equals to 1. This part and this part are equal, so you do not have to stress much. It's the very same thing whenever we're talking about 3 plus 1, which is equals to 2, equals to 4, I mean, sorry for that. And then as well as 1 plus 3, which is equals to 4. Okay, so now you can check that. Okay, now this is cos squared x plus sin squared x, which will give us 1. So it's 2 multiplied by 1 divided by 2. 1 minus sin squared x is the same as what? Is the same as the cos squared x from the fundamental identities. So now you can divide these two, and then you remain with what? You remain with 1 divided by the cos squared x, and then you are done. So this is how you can prove the identity.